1125 variable ratio piston metering system. This particular unit has been built for a two-part urethane. Has a part B tank, has a part A tank. This is the metering section here. This is the mixed dispense head. This system also includes a anti-gel timer or pot life timer, which is used to prevent material from curing in the mixer, which allows you to use the same mixer over again. Because this is a urethane material, each tank is equipped with a pressure vacuum and an off switch. So when you're running the 1125, typically you're going to be in this position, pressure on the tank, which feeds material into the metering section. If at the end of the day, or it's going to be shut down for a weekend, what we normally do is move to the vacuum side. We pull a vacuum here on the tank, and after a couple of minutes of vacuum, we isolate the tank here, so the tank is now isolated from the environment, and that helps protect the material from crystallizing due to moisture. The actual metering section is here. We have the B metering cylinder and the A metering cylinder, and those are attached to this lever arm and are adjustable to allow you to change the ratio of the machine. This is the air drive cylinder, which is used in the dispense mode to pull the lever arm forward. The way the system works is part B and part A are stored in these tanks. Material or adhesive is fed under pressure from the tank through a three-way valve into the metering section. This is a single acting system, so material flows in to the machine through this three-way valve. So material under pressure in the fill position is going to flow into this valve. This valve is connected to this hose, which flows down into the metering cylinders. And as these fill, this lever arm is forced back. When the lever arm reaches its limit, it trips a switch. This valve then rotates 90 degrees, isolates the feed, and connects the metering cylinder to the dispense hose. So this lever arm moves back and forth, fill position, empty position, and when it reaches an empty position, it trips another limit switch, which then again rotates this valve back into the fill position and connects the inlet from the tanks to the cylinders. Way ratio is achieved as we have a resin and a catalyst, or a poly and an iso cylinder. And if it was a 1-to-1 system, they would both have the same size cylinders. For instance, if it was a 4-to-1, it would have something like this. The bore on this cylinder would be much smaller than that cylinder. And each set of cylinders has a range through which you can adjust the ratio. Once the material leaves the metering cylinders, passes through the three-way rotary valve, comes up into this dispense head. So the two materials are kept separate until they reach this mixed dispense head. And even at that point, they're kept separate out to this tip, which is where the static mixer is used, and that's installed here. So the materials then flows through the static mixer and mixes and dispenses. In some instances where you have a fast chemistry and this cures in 2 or 3 minutes, what you'd like to do is keep the static mixer alive. So what we'll add as an option is an anti-gel or a pot life timer. And this is adjustable. For instance, if you have a 3-minute material which reacts in 3 minutes, to keep the static mixer alive, you would set this at 2 minutes. And what that does, it sounds an alarm at the 2-minute interval, and then dispenses the volume of this material out of the mixer into a waste container, thereby keeping the static mixer alive. In some applications, it's important to know how much material is left in the cylinders if you're doing a specific volume for a specific part. So we can include as an option a near end of stroke switch. So as these pistons approach the end of their throw and the cylinders are almost empty, the switch will set an alarm and let the operator know that there isn't enough material left to complete the application. Every 1125 that's running a urethane has designed into the system a desiccant dryer, because one side of the metering cylinders has fluid and the back side has air. So on the back side of the cylinders, we dry the air that enters the cylinders as they're dispensing material. Another important feature using urethanes is a desiccant cartridge inside this container. This allows you to plug your main air in here, and all air then that circulates through the system is manifolded from here and is kept dry of moisture. So this is an all pneumatic system, with the exception of the anti-Jill pot life timer. And there are some controls on the front of the panel. And some of these are used for manually recharging and bleeding the machine when you first receive it. Run bleed switches for bleeding. There is lights on it. These are pneumatic lights, which tell you whether you're in the dispense or in the recharge mode. There's also the air cylinder controls are here. And by adding pressure here, you increase the flow rate on the machine. By reducing the pressure, you decrease the flow rate on the machine. So at the end of the shift or the end of the week, you want to remove any moisture that might be in these tanks. And the way to do that with a simple vacuum generator is to attach the main air to the vacuum generator side, go to vacuum here, move the slide valve down. Now we're pulling a vacuum on the tank. And once we get something showing on the gauge, we're removing moisture and air from the tank. So down around 20 inches of mercury, we think that's probably pretty good to turn the system off. We've now isolated the tank from the atmosphere. We have a slight vacuum in here to prevent the crystallizing of the isocyanate.